Hi everyone, my name is Fatima Zahra Benaddi. I'm a PhD student at Cadi Ayyad University in Morocco. My research project is about energy efficiency in buildings. Today I'm going to present a part of my work that is thermal behavior of local construction materials coupled with natural night ventilation in Marrakech, Morocco. My presentation outline is as follows. I'm going to start with a background, then the building description, follow with methodology, and finally result in conclusion. The consumption of the electrical energy in Morocco has increased from 487 kilowatt-hour per capita in 2000 to 911 kilowatt-hour per capita in 2014. And the projection of the energy need on the electrical energy consumption will grow by 5 to 6% during the years 2020, which should be close to 1000 kilowatt-hour per capita. On the other hand, the building sector is one of the most energy consuming in Morocco, as it consumes energy and affects the environment during all its phases. I mean design, consumption, and use. It represents 25% of the final energy consumption of the country. Nowadays, most buildings are constructed with manufactured materials that have high embedded energy, high carbon emissions, and high purchase prices as well. For this purpose, a building called BATERRE is constructed mainly with local construction materials at the University Cadi Ayyad, Marrakech, Morocco. It is a single zone building with 60 square meter area. It is oriented southeast. It has 8 openings, 1 wooden door, and 7 single glassed windows. The windows are protected by wooden shutters levers. An overhang effect was applied in the roof that exceeded 30 centimeters on each facade of the building. The roof of the building is constructed with hollow core slab insulated with reed panels and one layer of plasterboard and lime coating at the outside facade of the building. The walls are constructed with stabilized ceramic earth and one layer of plasterboard. Windows are single glass window with wood panel. The door also was constructed from wood. The ground floor is constructed with hollow core slab placed directly on the ground. In order to evaluate the effect of natural night ventilation, it was essential before applying the natural night ventilation to check if the weather of Marrakech adaptable for natural ventilation, and secondly, is the building designed for natural ventilation. To evaluate the adaptability of Marrakech climate to natural ventilation, a methodology developed by one is applied refers to the climatic potential of natural ventilation. It is calculated according to the number of hours when natural ventilation is possible, divided by the total numbers of hours in a year. After calculation, using on-city weather data measurement of Marrakech, the calculated CPNV is 59%. This clearly divulges the natural ventilation could be ideally utilized under Marrakech climate. As our main goal is to evaluate the natural night ventilation, it was essential to establish the favorable period of the year for introducing the natural ventilation to the building. Hence, the CPNV was calculated during 2 defined periods, daytime and night time. It can be the calculated result is presented in this figure. It can be observed from this figure that the beneficial period of applying natural night ventilation is during May to October, since the highest CPNV values are reached during this period compared to daytime. In order to evaluate the effect of natural ventilation in our case study building, TRNSYS software coupled with TRNFLOW software was used. The model validation methodology was presented in a previous work. In reference to, the building is considered as a classroom occupied with 15%, and the occupied period was from 9 a.m. to 3 p.m. The first studied parameter is the indoor operative temperature. According to this figure, it is noted that the natural night ventilation significantly reduces the operative temperature in this building during the period of application of natural ventilation. The difference between these two scenarios, I mean without natural night ventilation and with natural night ventilation, vary between 0.2 degrees C and 2.3 degrees C. The second studied parameter is the cooling load. The following figure represents the cooling load for the two studied scenarios. In order to evaluate this, the set temperature considered was 26 degrees C, and the thermal loads were calculated during the periods of occupation only, without considering the weekends. From this figure, establishing the scenario with natural night ventilation resulted in a significant reduction of 17% of saving in annual cooling loads compared with without natural night ventilation. This results promotes and increase the efficiency of natural night ventilation in a semi-arid climate of Marrakech. To conclude, the adaptability of natural night ventilation to Marrakech climate is evaluated using local meteorological data. Was presented. A case study building of a classroom constructed mainly with local constructed materials is used. The operative temperature of the building is decreased by up to 2.3 degrees C when natural night ventilation is applied. The natural night ventilation scenario performs 17% reduction of the annual cooling load compared to the scenario without natural night ventilation. For future world, we'll be focusing to optimizing the building envelope to improve its thermal performance. And thank you for your attention.